Okay, everyone, so this is video 2 for the lesson 17 mini lesson. So we are studying parallelograms, and the first video explored what a parallelogram could look like. We learned about its attributes having to do with two sets of parallel lines, and we learned some things about the angles of parallelograms. So now I want to talk about diagonals. Okay, so I'm going to draw some diagonal lines on my parallelogram here. So a diagonal line is going to extend from one vertice to another, so it has to go across like so. And then I'm going to draw another diagonal from angle A to angle C. Okay, so I've now drawn two diagonal lines. And I'm going to measure each diagonal. Okay, so let's see. I'm going to start here. Okay, so my diagonal from A to C is 4 inches. And my diagonal from D to B is 5 inches. Okay, so what we're seeing is that the diagonals of this parallelogram are not equal to each other. So well, if we were working together, I would tell you what to do. And sometimes I forget that you're not following along with me. Maybe you are. So if you are following along, then please do this as I do. Okay, so here's what we're going to do. We're going to label the point where the diagonals intersect. What that means is when I ask you where do they intersect, where do they cross over each other? Where do they come together? And so that's going to be right here. So I'm going to label the point where the diagonals intersect as M. And so now I'm going to measure from each corner to M, and I'm going to write down that measurement. So from A to point M, this is 2 inches. From C to M, that is 2 inches. From M to B, that is 2.5 inches. Can you take a guess of what you think M to D is going to be? 2.5 inches. Okay, so we can see that from our vertice to our intersected point, that is half of that original length. So originally, line AC was 4 inches and line BD was 5 inches. And we can see that when we measure from the midpoint, from where they intersect to the angle, that it's half of that. Okay, so here's one of the things that goes with this is these diagonals, what happens is the diagonals of a parallelogram bisect each other, okay? So if we think about that word, bisect, we can think how many wheels are on a bicycle. We know that 2 wheels are on a bicycle. So section means, that's parts of something. A section is a part of. So if we kind of put those things that we know together, when something is bisected, it's cut into 2 parts. So when we bisected line AC, we cut it into 2 parts. And what we found is each of those parts is the same length. It has the same measurement. Okay, so just to kind of show you, if we were in the classroom and your partner drew a square and we did kind of the same thinking, we know that a square is a parallelogram because it has 2 sets of parallel lines. Okay, so we're going to see if this thinking works. So I'm going to draw my diagonals. This is where they would intersect. Okay, so in a square, what is that? This is not quite 3. So 1 and, let's see, this is cut into 3/8. 1 3/8 inches. And if I measured this one, that's going to be the same, 1 3/8 inches. Okay, now remember, in a square, all the side lengths are the same. So what do you think is going to be the length of each section here? Do you think it might be the same as 1 3/8? I'm thinking so. Yep. 1 3/8 inches. And if I turn and measure this one, that's 1 3/8. Okay, so in a square, each diagonal is the same length. So if you were sitting next to your partner and they drew their own parallelogram and we did this activity, you would probably notice that you have different lengths, but you would notice that where the diagonals are bisected, they are of the same length on either side. Okay, so let's recap. Parallelograms have 2 sets of parallel lines. They're going to have 2 pairs of angles that are the same measurement. The diagonals are going to be bisected and their length will be the same on either side. You may find that you have 2 different lengths of your diagonals in a parallelogram. It depends on how it is drawn. Okay, so I've been adding. So we talked about quadrilaterals. Quadrilaterals consist of 4 different points, A, B, C, and D. Means they have four sides, and those sides are A, B, B, C, C, D, D, A. Okay, we learned trapezoids yesterday, quadrilaterals that have at least 1 set of parallel lines. And now we're adding, I'm going to get a different pen. Okay, now we're adding parallelograms. And a parallelogram is a quadrilateral in which both sides of opposite sides are parallel. That's our key factor there. Okay, so we've added something new. The next video will be working on the problem set and looking at some further examples of parallelograms. Okay, thanks.